All right, Algebra 2. Here we go, section 3.5, linear equations in 3 dimensions. So, we're going to first label our axes here. I have 3 axes instead of the 2 like we've been working with all year. So I will have an x-axis here, my y-axis, and my z-axis. So in 3 dimensions, we're going to have to kind of switch our mentality a little bit here. Now, it's important to understand, x is not actually the axis that's going diagonal. That is actually the axis that is coming out towards you or moving out kind of in the direction you're looking at. In other words, it's forwards and backwards. It's not diagonal, but we draw it diagonally because it kind of gives the illusion, at least, of 3 dimensions. And we're drawing on a 2-dimensional piece of paper, so that's the best we can do. My y-axis is going to move left and right, positive, negative, and my z-axis is up and down, positive, negative. A positive x value is coming at you. A negative x value is moving away from you. All right, so if I go ahead and try to graph this, first coordinate, which is 1, 3, negative 1, my coordinates are going to be just like they were in 2 dimensions, x and y, except for now I have this third coordinate, z. All right, so my x coordinate is 1. I'm going to move forward, kind of along the diagonal, but move forward towards you 1 unit. So about there. Going back to the origin now, I'm going to count over 3 spaces. So back at the origin, count over 3 spaces. 1, 2, 3. And I'm just eyeballing what those tick marks are. And I'm going to try to draw kind of a dotted line like so, kind of to give the illusion that I'm on that XY plane. Now from there, I'm going to drop down 1 unit. So from this point right here, let's drop down 1 unit. And I don't know, that's approximately 1 unit right there. And we'll give that a nice little label of 1, 3, negative 1. Now I'm glad that you are viewing this video because I'm sure that not all your classmates are. But I really want you to practice drawing these with me. I think that's going to make tomorrow in class go a little bit smoother for you. All right, the next one. Point E is at 1, negative 3, 1. So again, x coordinate would be 1, y coordinate is negative 3, and z coordinate is 1. So we'll go ahead and we'll graph that. So I'll come forward 1 unit again to right there. But this time I'm going to go to the left 3 units, but I'm starting again back here at my origin. So I'll count out 3 units. 1, 2, 3. So currently I am located, I'm going to draw some parallel lines here. Parallel to the y-axis, parallel to the x-axis. Just again trying to give that illusion of I'm on this xy plane. And now from there it tells me I need to go up 1 unit. So from right here, let's count up 1 unit to, well, I don't know, maybe about like so. Notice I'm not using my z-axis here, kind of making labels. I'm not doing that. We're just estimating how far up and how far down we are. So this coordinate is at 1, negative 3, 1. All right, 0, 0, 3. I'm not moving left. I'm not moving right. I'm not moving forward. I'm not moving backwards. I'm sitting right here right now. And now from there, I'm going to go up 3 units. Now, since I'm on this axis, I could go ahead and kind of count 1, 2, 3. And that's where I'd be sitting at 0, 0, 3. Okay. So I'll work with you a little bit more if you have questions on the graphing side of things. But it's drawing these parallel lines here and here that sometimes give people troubles. And again, when you are on the XY plane, when you raise up and down, don't use your z-axis. Just eyeball it approximately from that point where it is. Okay? All right. So let me just give you one more example here that's not on here. And let's say I wanted to graph the point. Let's do negative 4, 5, 3. So I'm going to move from the origin. I'm going to start and move back, kind of like towards Mr. Sullivan's room, if you will. So I'm going to go move back 4 units. 1, 2, 3, 4. And from the origin, I'm going to move to the right 5 units. 1, 2, 3, 4, 5. So I'm going to try to draw some parallel lines here to give that illusion of being on the XY plane. So something about right there. And now if my coordinate was negative 4, 5, 0, that's where I'd be. But from here I have to go up 3 units. So we'll count 3 units up, eyeballing it. 1, 2, 3. Maybe about to right there. So that is at negative 4, 5, 0. Okay. Let's go ahead and take a look at this problem. Planes. Hopefully you remember from geometry, 2 points determine a line, 3 points determine a plane. So I'm given this linear equation, x minus 4y plus 2z equals 4, and I'm going to graph this in the, I guess, 3-dimensional space. To do this, I want to find the x-intercept, the y-intercept, and as you probably guessed, the z-intercept. So how do I do this? I think you guys probably could figure this out. To find the x-intercept, ask yourself what has to be 0? Well, y has to be 0, and z has to be 0. So when those are zeros, I'm going to have x minus 4 times 0 plus 2 times 0 equals 4. Those will drop out. X would equal 4. So I'm going to have one coordinate at 4, 0, 0. So let's go ahead and graph that. So I'm going to come forward 4 units. 1, 2, 3, 4. About like so. All right, so there's 4, 0, 0. Now let's go ahead and find the y-intercept. So to get my y-intercept, as you probably guessed, x has to be equal to 0, and z has to be equal to 0. So I will have 0 minus 4y plus 2 times 0 equals 4. Or in other words, negative 4y equals 4. So therefore, y would be at negative 1. So my ordered pair for, or ordered triplet would be 0, negative 1, 0. So I don't go forward or backwards. I go left 1, but I don't go up or down. So that's where my point is, right there at the coordinate 0, negative 1, 0. And now we have our last one. Let's go ahead and find our z-intercept. So to find that, x is going to be 0, y will be 0. So I'll have 0 minus 4 times 0 plus 2z equals 4. So 2z equals 4. Z would equal 2. So my coordinate here would be 0, 0, 2. Graphing that, don't go forward backwards, don't go left, right, but I'm going to go up 2 units. 1, 2, to about there. Now, how do I graph a plane? Well, once you have your 3 points, honestly, it's playing connect the dots and it's making a triangle. So I'm just going to go like so, and like so. And again, if the calibration wasn't off, you'd see that I have kind of a triangle here. But it doesn't look like it. But it is a little triangle. That's how you graph the plane. Find the x, the y, the z-intercepts, play connect the dots. Last problem we have to take a look at here is a story problem. Steve's going to go on a little hiking trip. He spent $61.50 and bought some items here. We need to write a linear equation with those 3 variables. So it looks like to me, my equation then would be 6150 is going to be equal to, well, let's see. He bought some flashlights for $3.50 each. So let's do $3.50 for F times F, however many flashlights he bought. And then some compasses that cost $1.50 each. Probably use the variable C for compass. And some water bottles that cost 75 cents each. Times, oh, I don't know, W probably. All right, so that was pretty easy. Write my equation. And now the question is just asking, all right, if Steve purchases 6 flashlights and 24 water bottles, how many compasses did he purchase? Well, 6150 is going to be equal to 350 times the number of flashlights he purchased, which was 6. Add to that $1.50 for each compass, which is what I'm trying to find, so I'll leave my variable as C, plus the number of water bottles, 75 cents per water bottle. In this case, that was 24. So after doing a little number crunching, I will have 6150 will equal 21 plus 150 times C plus 18. Get my variables by themselves, so subtract 21, subtract 18, and I'm going to be left with 22.5 will equal 1.5 times c. Divide by both sides by 150, and c is going to equal 15. Why Steve needs 15 compasses is beyond me, but that's not what the problem's asking. I'll let you debate that and dream about that, and we'll talk about it tomorrow. Have a great day.